Hi everyone, my name is Jaylee Willis and I'm the owner and founder of Middleton Math. I'm really excited to be offering this webinar about the art of playing math because what I've observed is that when students learn math through a playful, creative, exploratory process, first of all, they have a lot more fun with math than just doing math, but they also tend to understand the math better because they're learning the math in the context of something that is important to them. So in this video, we're going to be talking about 5 principles that I use in my classes to make math fun and engaging. And my hope is that through the sharing of these principles, it helps you as parents create cultures of mathematical creativity and exploration and play within your own family cultures. So to start off, I'd like to share a little bit of my background and where I'm coming from in terms of why I love math. So I grew up as the oldest of 11, and our family was homeschooled for much of our childhood. Not all of it, because sometimes we would try out other schooling options, but for most of the time we were homeschooled. And my mom was an elementary school teacher before she started having kids, and she loved teaching us math in really visual ways, which helped us understand math a lot better. And my dad was an engineer who decided to have a career as a builder in construction. And he loved doing mathematical puzzles with us. And because of the way that my parents taught us math, all of my siblings really enjoy math and do really well in math. And when I grew up, I decided to become a math teacher, and I got my bachelor's degree in math education. And I taught for an online middle school, high school for about 7 years. And then after that, I decided to go back to school and get my master's degree, and now I teach at a university in southern Utah. And I love teaching students of all ages and all educational backgrounds, but I have a special place in my heart for homeschool families because I was homeschooled myself. And from what I've observed, a lot of homeschool families are very creative and very passionate in the way that they educate their kids in a lot of subjects, but math usually is one that they struggle with. And so my goal with my company in my math classes is to make math really easy for homeschool families. And the principles that I use to help make math easy are playfulness, visualization, curiosity, application, and mastering the basics. So in this seminar, I'm going to go through these 5 principles and share tips and tricks that you can use to implement these 5 principles in your family's math experience. So the first principle is playfulness, and I'd like to share a story that happened to my family this winter that really illustrates how my dad helped our family experience math in a very playful way. So earlier this winter, my dad sent out a text to our family group chat, and he said, here's a number sequence. The number sequence is 3, 15, 35, 63, 99, and 143. And he asked us, what functions do you see that produce this sequence? And part of the reason why this text message got the response that I'll show you in just a minute is because my dad would do this all the time while we were growing up. He would give us fun patterns and ask us to find the next number in the pattern. Or he'd give us like math problems as a quiz, but in a playful way where there wasn't any high stakes of like, oh, we had to get the answer right. It was just a playful, fun activity to do as a family. So before I show you guys the responses, I want you guys to look at this sequence of numbers and see if you can figure out what the pattern is. So pause this video and take as long as you'd like to look at this sequence of numbers, and then I'll show you the response that my siblings sent. Okay, so my first sister that responded and thought that she had found the pattern said that the pattern that she noticed was that you multiplied consecutive odd numbers. So 3 times 5 gives you the 15, 5 times 7 gives you the 35, 7 times 9 equals the 63, 9 times 11 gives you 99. And basically you just multiply consecutive odd numbers together. And my dad responded and said, yes, that's one of the ways that I'm aware of. And my sister was like, wait, what? Like there's multiple ways you can do that in more than one way? And my dad, this is one of the ways he brings playfulness in. He said, yeah, like that's the way Mom saw it, and Josh saw it another way. And I wonder if there's even more ways that you could find this sequence of numbers. And the pattern that I saw, which was a different way than my sister saw, was that you square even numbers and subtract 1. So 2 squared minus 1 gives you the 3. 4 squared is 16 minus 1 gives you the 15. 6 squared minus 1 is 36 minus 1, which is 35. 8 squared is 64 minus 1 is 63, and so on. And that was apparently the way that my dad saw the pattern. And we were all like, don't tell us what the next one is. Like, we want to see if there's, like, if we can figure out what the third way is. And my sister was the one who figured that one out. And what she noticed is that if you take the first number, so you do 3 plus 12, that gives you the next number 15. And then 15 plus 20 gives you 35. 35 plus 28 gives you 63. So essentially, she looked at the difference between each number in the sequence, and she noticed that the numbers were increasing by 8. So like 12 plus 8 gives you 20, 20 plus 8 gives you 28. And so like the next number would be 63 plus 28 plus 8 more than 28. And that would give you the next number, which was 99. And I wanted to share this story with you because this is an example of how math can be taught in a really playful way. So I'd like to share some tips about how you can make math more of a playful experience within your family. And the first tip is to look for patterns. So for example, if your kid was learning how to multiply by nines, you could first teach them the meaning of multiplication, which is that you're making a certain number of copies of something. And you could say, okay, like if I have 2 things and I make 9 copies, and you could show this with physical objects, they could count out all the objects and they'd realize that the answer is 18. Then you could say, okay, well, what if I have 3 things and I make 9 copies? And then they'd figure it out and find out that the answer is 27. And they would continue on, and you don't have to get very far before there's a pattern that your kids could use to memorize the 9 times tables. And I would encourage you to have them find their own pattern. So the way that I would describe this pattern is that if you do 6 times 9, the number in the tens column is 1 less than 6. And then the number in the ones column is the number that you would add to that number to get the number 9. So that's the way that my brain thinks about it, but your kids might have a different way of thinking about it. Like they might notice that the pattern in the tens column is that you're counting up, and the pattern in the ones column is that you're counting down. And whatever way they look at it, it's going to help them understand the 9 times tables and be able to memorize them more easily. So that's the first tip, is look for patterns. The second one is to play games. And there's all sorts of math games that are available. And if you would like to, you can sign up for my email list at middletonmath.com. To get my monthly newsletter where I send out free games and activities and different things that you can do to help your kids have a more playful experience with math. So I'm not going to go into a ton of detail on this because there's lots of different games that are available. But the third tip I have is to do car quizzes. So car quizzes are basically like when you're driving and you're not really doing anything anyway, you can quiz your kids on different math ideas. So for example, if you were driving down the road and you passed a really tall building with a whole bunch of windows, you could say, hey everybody, like look out the window. Do you see that building that has all those windows on it? And you could say, how many windows do you think are on this building? And by this point, you've probably already passed the building, so you can just make up some numbers and you can say, like, let's say there were like 12 windows along the top and there's like 13 floors in the building. How many windows would be like on the entire building? And assuming they know how to multiply and stuff, they could figure that out. And you can do this even if you're not in the car, but this is something my dad would do with us a lot. And it really brought an aspect of playfulness into our math experience. And some of the words or phrases that you can use to help your language become more playful is kind of like a curiosity-led question where you're like, what would happen if we did this? So like if you're learning one type of math problem and they figured it out, you could say, what would happen if we changed this number? How would that change the result? Another phrase that you can use, especially if your kids have not had a playful experience with math in the past, is you can ask them, do you want to play math or do you want to do math today? Because this question will kind of help them separate it in their brains from any previous math experiences they've had. Because if you start trying to do more playful experiences with math, they might be like, oh, like I don't like math, and, have a bad attitude about it because of their previous experiences with math. But if you give them this distinction by asking them the question, do you want to play math or do math, then they can start to disassociate the negative experiences with the topic of math. And if they say they want to do math, then you can do math the way you've always done it with them. And if they say you want to play math, then you can give them a new experience of doing math. So those are my suggestions for how to make math more playful. And to introduce the second principle, I want to do an activity with you. So for this activity, you're going to draw 2 pictures. So I'll have you pause the video and draw these 2 pictures. And the first picture is going to be the picture of a pig. And the second picture is going to be a picture of the number 3. So pause this video and draw a picture of a pig and a picture of the number 3. Okay, so now that you have your 2 pictures, I want you to look at your picture and identify which one of these 2 options does your picture look the most like. It's probably not going to look exactly like it unless you're like a professional artist, but which picture does yours look the most like? And if you're like any of my students that I've ever done this activity with, your picture looks something like this. And it doesn't look like this because I asked you to draw a picture of a pig. I didn't ask you to write the word pig or to spell the word pig. I said to draw a picture of a pig. So now let's take a look at your second picture. So when I asked you to draw a picture of the number 3, which of these 2 options does your picture look the most like? And I've done this with tons and tons of students. I do this with my college students almost every semester. And most of them will always draw something that looks like this. However, this is not the number 3. The number 3 is the idea of having 3 things. And this is just the symbol that we use to represent that idea. Just like we use the word pig to represent the idea of the animal of a pig, the number 3 is the idea of having 3 things. So drawing a picture of the number 3 would look something more like this. And it doesn't have to be circles. You could have 3 stars or 3 people or 3 boxes. But the idea of the number 3 is that you have 3 items. And this is just a symbol that represents that idea. And this is one of the reasons why I feel like people struggle a lot with math, is because from the very beginning, we teach kids to memorize math instead of really explaining the concepts behind it. Like even when they learn how to count, they memorize that the way you count is 1, 2, 3, 4, etc. And if you've ever listened to little kids count, they often skip whole sections of the counting sequence. And they'll say like 1, 2, 3, 4, 7, 8, 9, 10, and they'll skip a bunch of numbers. And I don't know if this is accurate because I haven't scientifically tested this, but I have a theory that people start to struggle with math a few years after they start memorizing it. So some kids will start struggling with math around 2nd grade because the way that they learned numbers was through memorizing counting. But some kids get a conceptual understanding of what numbers are, and they understand that when you do 2 plus 3, you're adding 2 things and combining them together with 3 things, and that makes an amount of having 5 things. So they'll find addition and subtraction to be relatively easy, but maybe they'll start memorizing once they get to multiplication. And by the time they get to fractions, they'll start struggling because they memorize multiplication instead of really understanding what multiplication is. And other students will be fine through addition and subtraction, multiplication, division, and they'll even understand fractions. But then once they start algebra, then they start memorizing processes. And by the time they get to pre-calculus, they're confused. So again, I don't know if this is a official theory. I haven't scientifically tested it. But from my experience teaching math to a variety of ages over the years, this is my theory about why people struggle with math. And so the second principle that I use to help make math really easy for my students is to help them visualize all of the concepts that I teach them. So for example, if I was teaching long division and we had 425 and we wanted to divide it by 3, I would visualize this by showing them that 425 can be represented with base 10 blocks, where you have 4 hundreds, 2 tens, and 5 ones. And then I would go through the entire process of long division and show them why it works. So when we say 3 goes into 4, how many times? Instead of asking it in that way, I would say, okay, if I have 4 hundreds and I want to split it up into 3 groups, how many hundreds will I have in each group? And we'll do this physically and we'll say, okay, well, here's 100 in each of these groups. And I don't have enough hundreds to put 2 hundreds in each group because I only have 100 left, but I have 3 groups. So we'll say, okay, well, when I take 4 hundreds and split it up into 3 groups, I have enough to put 100 in each group. And when I put 100 in each group, I've taken care of dividing up 3 of my hundreds. So I'm going to subtract 300, and that tells me that I have 100, 2 tens, and 5 ones left to divide, which we can see in our visual picture here because I have 100, 2 tens, and 5 ones that I haven't split up into 3 groups yet. And then we say, okay, well, if I have 125, we already know that this 100 can't be split up into 3 groups. And so I'm going to exchange this 100 for 10 tens, which gives me 12 tens altogether because I have these 10 tens and these 2 tens as well. And so when I take those 12 tens and I divide them equally into 3 groups, you can do this one at a time, and you might want to ask your kids to predict how many will be in each group. So you'd say, okay, well, it looks like we have 2 in each group. And if your kids know their times tables pretty well, they're probably going to know before you finish this that there's 4 tens in each group. But you can show that visually by putting 4 tens in each group, which means that our answer is going to have a 4 in the tens column, and I can subtract 12 tens, which you can also write as 120 because 12 tens is 120 items. And when you subtract that 120 items that you've divided out, you have 5 items left to divide. And again, you can see this visually because you have these 5 ones that still need to be divided up. And so you say, okay, well, if I have 5 ones and I put them equally into 3 groups, how many will be in each group? And we'll get the answer that there's 1 in each group, because if I put these into our my 3 groups, then I have enough to put 1 in each group. And when I do that, I can subtract the 3 ones that I divided, and I have 2 ones left. And depending on the level of math that your kids are at, you can either just write this as a remainder and say that there's a remainder of 2, or if they know about decimals, you can bring down the next place value and you can say, okay, these 2 ones could be split up into 10 tenths each, which would give you a total of 20 tenths, and you could divide up the tenths. And then if you have any leftover tenths, which in this case you would, you could divide the tenths up into hundreds and thousands and so on, if your kids know about decimals. But when you first start teaching long division, it'd probably be easiest just to write it as a remainder, because usually they don't know about decimals at that point. So the tips that I have for helping your kids visualize math more are to draw pictures and use manipulatives. So when your kids draw their own pictures of the mathematical concepts you're exploring, you can see what their misconceptions are, and it will also help them develop their own strategies for solving the different problems that you're working through. And my favorite manipulatives that I like to use for whole number operations are base 10 blocks. So you can buy these on Amazon, they're really cheap, and you can buy physical versions of them, or you can also use apps. And I actually prefer using the apps, partly because I teach online, so it's easier to just share my screen and share the app. But I also really like using apps because when you're splitting up the blocks, like splitting 100 up into 10 tens, the apps just have a button that you can click and it automatically splits them up into 10 blocks. Versus if you're using physical blocks, you have to count out 10, which means that there's more room for error if your kids count out the wrong number of blocks. So I really like using apps, but physical blocks are also great, especially if you have a kiddo who really likes doing like physical tactile things, and that's really good for their learning style. So in either case, it totally works. I also really like using circle fraction manipulatives and number line fraction manipulatives. And again, you can get physical copies of these, or there's also apps that you can get for these types of manipulatives. So when you're visualizing or trying to figure out how to visualize a concept for your kids, the question you want to ask is, why does this process work? So for example, if you are learning about how to reduce fractions, well, the process for reducing fractions, like 12/18, is you find a number that both numbers can be divided by. So in this case, that number would be 6. And if you divide the top and the bottom by 6, that gives you the fraction 2/3. So that's the mathematical calculation process for reducing fractions. But if you want your kids to understand this concept well, it's better if you can help visualize it. So you might say, okay, well, how could I visualize 12/18? And maybe you use a circle model, maybe you use a number line model, but you have some visual representation of 12/18. So in this case, I have a circle. And then we say, okay, well, the fraction 2/3, if we were to draw a picture of that, would look like this. And so you can ask yourself and say, okay, why does this amount that I have shaded in yellow, why is that equal to the amount that I have shaded in blue? And ideally, you would want to have circles that are the same size, but my slide is a little bit small, so I'm just giving you the basic idea. And you could look at it and you could say, okay, well, this process of dividing by 6, well, 18 divided by 6 means that I have 18 things that I'm dividing into 6 groups. And so what that would look like is I'm dividing these 18 things into groups of 6. So here's one group of 6, here's another group of 6, and here's another group of 6. And that gives me 3 things all together in my whole. And the 12 pieces that were shaded, when I divide that by 6, that gives me the number 2, because those 6 little pieces that were all stuck together into a single piece makes 1/3, and then the other 6 pieces makes 2/3, and that's the reason why 12/18 equals 2/3. So the main question you want to ask yourself when you're trying to bring more visualization into your family's math lessons is to ask, why does this work? And then draw pictures or use manipulatives to understand why it works and to get a visual picture of whatever the concept is. And then the third principle that I use to help make math fun for my students and to make it easy is curiosity. So I want to tell you a story about my little brother Joseph. So when Joseph was about 14, he had this t-shirt that said something like, "I love pizza pie." And on the t-shirt, there was the symbol pi, but he didn't know what pi was at that point. So he asked my mom one day and he was like, "What does this symbol on my shirt mean? Like, I know that it's a math symbol, but I don't know what it means." And I was at home at the time, so my mom was like, "Well, Jaylee's a math teacher, why don't you ask her?" And I had some extra time, so I decided rather than just telling him what pi was, that we would do an exploration to discover what pi was. And so what I had him do is I had him measure a whole bunch of different circular objects. And I told him that pi has something to do with the relationship between the distance around a circle and the distance across the circle at the widest point, which is its diameter. And so he measured a whole bunch of different circular objects, like he found a bowl and found that the circumference was 25 inches and the diameter was 8. He measured a cup, which had a circumference of 40 centimeters and a diameter of 12. And basically we measured all of these different objects to figure out what the circumference and what the diameter was. And I suggested that he should measure them in different units so that we could see if the relationship was consistent regardless of whether you use inches or centimeters or things like that. And so he even wanted to measure the circumference of our trampoline, which was this one. So we had a circumference of 51 feet for the circumference of the trampoline, and the diameter was 16 feet. And then my favorite one was our circle driveway, because our family's house has a circle driveway. And we didn't have anything that we could use to measure something that big. So we asked my dad how big it was because he was the one who built it. And my dad was like, oh, well, I think the diameter is about 100 feet and the circumference is about 314 feet, which made me laugh because our circle driveway is nowhere near 100 feet in diameter. It's probably about 40 feet in diameter. But my dad knew what we were trying to figure out, so he just made up numbers that would work well for what we wanted to do. So once Joseph had measured all of the circumference and diameters for all these different circles he picked, then I had him divide the circumference by the diameter because I kind of gave him the hint that the relationship has to do with division. And when he divided them, he got all of these different numbers. And when I looked at them, I said, okay, well, like, do you see a pattern here? Do you notice anything consistent between all of these numbers? And he said, well, almost all of them are 3. But there's this one number that isn't 3, but it is really close to 3 because 2.75 is closer to 3 than it is to 2. And I was like, yeah, exactly. And that number is pi. Because if you were to perfectly measure all of the circles and all of their diameters, the ratio between the circumference and the diameter would equal 3.14159. And I told him that this decimal goes on forever. And that's the decimal you would get if you could measure a circle perfectly and divide it by its diameter. And so we also talked a little bit about how measurements often have errors. So like this one, for example, that one was pretty far away from the other numbers, which were like 3.1 something. And we realized that when he measured that object, his measurement had been rounded a little bit, and that was what had made that number a little bit different. And same thing with this number, which was a little bit farther away than the rest of the numbers. We realized that when he measured that object, it was actually a log that was not perfectly circular. So it was kind of oval shaped, which is the reason why the circumference divided by the diameter was not as close to the value of pi. And this story that I experienced with my brother is something that illustrates the first tip that I would recommend to bring more curiosity into your family's math experience. And that is to maximize any questions that your kids ask that are mathematically related. So your kids are not always going to ask questions like my brother did. It's not like he was asking questions like this every day. But when your kids ask a question like this, you can maximize their curiosity by exploring it rather than just giving them the answer. And you also can bring in curiosity even if it's not something that they bring up through a question. And the way you do that is by creating I wonder questions. So an example of this would be an experience I had with one of my sisters a couple years ago. So I was in grad school and I was teaching a group of elementary teachers or students that were going to become elementary school teachers about a concept called other bases. So our number system is base 10, which means that you count up to 10 and then you change place values. So 10 ones becomes a 10, 10 tens becomes 100, 10 hundreds becomes 1,000, and so forth. And in other bases, you'll have another number instead of 10. So for example, in base 6, if you have 6 ones, that makes the next place value. Then 6 of those makes the next place value, and 6 of those makes the next one. And this is a concept that my college students often struggle with because it's basically defining an entirely new number system that's different from the number system that we grew up with. And I was wondering if it was possible for a little kid to learn this other number system. So the topic that I wanted my sister to learn was this idea of other bases. And the way that I created curiosity around this was by creating an I wonder question. So the thing that I asked her was, what would happen if we were aliens and instead of having 10 fingers, we only had 6 fingers? That was the I wonder question. And through a discussion that she and I had for about, I think it took about 2 hours, she created an entirely new number system for aliens. So we started off by talking about how aliens would probably use different symbols because the symbol that we use to represent the number 3 may not necessarily be the same symbol that aliens would use. And so she decided to make up, with a little bit of suggestion from me, to use a triangle to represent the number 3. And then she used a square to represent the number 4, a line to represent the number 2, and a dot to represent the number 1. And then for the number 5, we didn't want to have to draw pentagons because pentagons kind of look like squares if you draw them fast. So we decided to use a star to make that symbol a little bit easier to draw. And so we came up with these different symbols, and we realized that when you count up to 6, so like on alien fingers, if you count up to 6 on your fingers, then we should change place value, just like when you count up to 10 on our fingers, that we write 10 as a 1 in the next place value and a 0 in the first place value. And so she decided to call this number Dotty, kind of like 20 and 30. And she called this number Dot because we also realized that aliens might use other words to represent the numbers. And through this process, she created this whole system where the number system was based on having 6 fingers instead of having 10 fingers. And by the end of this conversation, she actually understood the concept of base 6 blocks or base 6 number systems better than almost all of my college students. So this is an example of how an I wonder question can create curiosity around a topic that kids may not necessarily ask their own questions about. Like, it's not something that my sister probably would have thought of to say what types of number systems are possible if you only have 6 fingers instead of 10. But it was an interesting question that she was interested in exploring because I created it in a way that naturally sparked curiosity. So another way that you can help bring more curiosity into your family's math lessons are to realize that mistakes are learning opportunities and to let them be learning opportunities instead of just saying, oh no, that's wrong. So for example, when you learn how to add fractions, a common mistake that kids will often make when they first start is that they'll add the numerators and denominators together. So 3/5 plus 1/5, they'll say is 4/10 because 3 plus 1 is 4 and 5 plus 5 is 10. But you can help them learn from this mistake by saying, okay, well, that's a really good guess. Like, I think that makes a lot of sense because like 3 plus 1 is 4 and 5 plus 5 is 10. Let's draw a picture of it and see if it makes conceptual sense with the pictures. So this is kind of going back to the visualization idea. And if you draw a picture of 3/5 and 1/5, it's pretty obvious that combining those together does not equal 4/10 because these pieces are bigger than tenths are. And so your kids, if you draw a picture of it, they'll automatically correct themselves and say, oh no, it's not 4/5 or it's not 4/10, it should be 4/5 because the 5 tells us how big the pieces are, because it tells us how many pieces are in a whole, and the size of the pieces doesn't change when we combine them together. And so you can use something like this to use a mistake as a learning opportunity instead of just saying like, oh no, that's the wrong answer. And you can also use curiosity to extend concepts. So let's say you had added a whole bunch of fractions that had the same denominator. Well, then you could use curiosity to extend this and say, okay, well, what if we had two different numbers in the denominator? Like if we had 2/3 plus 1/2. Well, in that case, we know that we have three pieces of the circle, but we have a problem because there's like some of them are thirds and some of them are halves. And so you could use curiosity to extend this concept to figure out what you would do in this case. And so your kids might look at it for a while and kind of be confused, and you could say, well, like the main issue is that the pieces aren't the same size. So what if we could make them the same size? And we could cut them up into smaller pieces that are all the same size. And if you do that and you say, okay, well, what happens if I cut the thirds into halves? Well, that makes sixths. And you might notice that this line is cutting it in half, and each of the halves have 3/3 within them, or 3/6 actually. And so you could say, okay, well, that means we could also cut the halves into thirds, which would also make sixths. And in this case, all of the pieces would be the same size. And you'd say, okay, well, the 2/3 that we used to have are now 4/6. The 1/2 that we used to have are now 3/6, or is now 3/6. And when we add these together, that gives us 7/6. And again, this is going back to the visualization concept, because what I just did on these pictures here is the same as what you would do calculation-wise, because the way that you find common denominators is you do 3 times 2 and 2 times 2, so you multiply the top and the bottom by the same number. And the reason why we multiply by 2 in this case is because each of these thirds was split up into 2 more pieces. And same thing with the half, when you do the top and the bottom multiplied by 3 to get the common denominator of 6, that's splitting up the halves into thirds. And so to summarize, the ways that you can bring curiosity into your math lessons are to maximize the questions that your kids ask naturally, create I wonder questions around the topics you want them to learn, but maybe they're not asking questions about, realize that mistakes are learning opportunities, and then extend concepts by making the problems more difficult after they understand the basic concept. And then the fourth principle is application. So ultimately, math is helpful because you can apply it to various situations in real life. So you really want to draw this out through your math explorations and make it so that word problems are the best part. And the way that I've found most natural to do this is not to just do word problems from a textbook, but to make up your own word problems. And be playful with this, and remember, it doesn't have to be realistic for your kids to get a lot of value out of it. So the way that you create a meaningful word problem is you ask, when do we actually use this? So for example, fractions are used a lot in cooking. So you might create a scenario related to cooking. Or they're also used, or especially decimals are used when measuring distances. So if you're going on a family road trip, you could create a word problem that involves decimals in regards to the distances that you're traveling. And one of the ways that I really love to create meaningful word problems in my math classes are with math adventures. So in my Middleton math courses for 3rd through 5th grade, we do what are called math adventures. And these are the meetings that we have on Zoom once a week. So the way that a math adventure goes is at the beginning of the semester, we all choose different characters that we want to be. So last year, I was a unicorn lady, and we had a fairy princess in our class, and a panther with wings, and a griffin, and a dragon. And we had all of these different characters that the kids chose. And every week we would go on these storytelling adventures, and I would weave math into it. So as an example, last semester, part of our adventure was that we met this Dragon King, and the kids helped me make up the story. So the kids decided to name this Dragon King Godzilla II. So we met the Dragon King Godzilla II, and the Dragon King had a list of unresolved issues that were causing problems in his kingdom. And the kids made up what the issues were. And one of the issues was that we had a village where everybody in the village was sleepwalking every night. And the Dragon King told us that he would pay us a whole bunch of gold if we could resolve these issues. And so throughout the course of the semester, we went through and resolved all of these issues. And when we got to the issue of the village sleepwalking, we went to the village, and the kids very creatively named this village Sleepwalking Village. And what we discovered while we were at the village was that there were these rocks in this cave in the village that were giving off a strange mist. And nobody in the village knew what was going on, but they told us that there was this lady who lived out in the forest who did know something about the rocks. And they didn't know if she would know the solution, but they knew that she knew something about the rocks. And so we decided to go out and visit this lady to get more information about these strange rocks that were giving off a mist. And so we said, okay, well, this lady lives 1.5 miles away, and we can only walk 1/7 of a mile every minute. And so if we can only walk 1/7 of a mile every minute, and she lives 1.5 miles away, how long is it going to take us to go visit this lady? And we drew number lines, and we talked about it as a class, and ultimately the kids came up with the solution, and we continued on our adventure. But I loved this specific part of our math adventure because this problem involves division of fractions, which is actually a very complex topic that even sometimes adults will make mistakes with. But because it was in the context of a word problem that they had created and they were invested in, the kids were able to create different strategies and come up with different ideas that ended up with the correct answer, even though none of them had learned about dividing fractions yet. And so this is one way that I like to bring application into my math classes, but there's many different ways you can do it. The main thing I just want to focus on is make word problems that are meaningful to your child, whether they're realistic or not. So you can apply it to the real life that is happening in your everyday lives, or you can also do something more fanciful, like I do with my math adventures. And then the last principle that I use to help make math really easy for my students is to master the basics. So it's really important that kids understand the concept first and then memorize. Because as we talked about in the visualization section, when you just memorize math, it makes it so that later math is much more difficult because you're just memorizing a bunch of facts instead of really understanding what it is that you're doing. So it's really important you learn the concepts first, but it's also important that you memorize the math facts, because if you're always skip counting to figure out what 6 times 8 is, that's going to make it a lot more difficult to do any future math after multiplication. So that's the first suggestion for mastering the basics, is help your kids understand the concepts first and then focus on the memorization. So for example, if you're introducing multiplication, we talked about this a little bit earlier, but you can teach your kids that 4 times 9 means that you're making 9 copies of 4 things. And it's very helpful when you're first introducing multiplication to just show this visually and to say, okay, I've got 4 things, and then I'm going to make 9 copies. So there's 2 copies, 3 copies, 4 copies, 5 copies, 6 copies, 7 copies, 8 copies, 9 copies. And your kids can either count up how many things there are, or this is another reason I really like the apps, because on the apps you can put 4 blocks and then make 9 copies of it, and then you can automatically regroup them, which can make it a little bit faster and easier for your kids to figure out that the answer is 36. And it's helpful to do this with a whole bunch of multiplication problems. So when I introduce multiplication, I have the kids do this for the entire times table to figure out what all of these different times tables are. And then after they have a really solid understanding of what multiplication means, then you can start looking for patterns to help them memorize. So we talked about this earlier, so I'm not going to go into a lot of detail, but the 9s have a very specific pattern that can make it really easy to memorize the 9s. Another thing that can be really helpful is to introduce thinking strategies. So multiplication means that you're making copies of things, But you can simplify the process of making the copies so they don't have to skip count or count up all of the objects. For example, if you have 8 times 7, this means that you're making 7 copies of 8 things. And maybe they don't have their 7 times tables memorized yet, but they do know their 5s and their 2s, because 5s and 2s are easy to memorize. And so if they have their 5s and 2s memorized, you can break this down and say, well, if I'm making 7 copies of 8, that's the same thing as making 5 copies of 8 and 2 copies of 8 and then combining them together. And so you'd say, okay, well, 5 copies of 8 is 40, 2 copies of 8 is 16, and 40 plus 16 equals 56. And I would not recommend writing this out because the process of writing can sometimes make it more complicated than it needs to be. So this is just to kind of show you the process of it. But this is more of a mental math strategy where you say, okay, well, if I make 5 copies and 2 copies and combine those together, that's the same thing as making 7 copies. And you can also do things like this for addition as well. So say, for example, you have 8 plus 6. A lot of kids will count out 8 things on their fingers, and then they'll add 6 more things to get the answer 14. But you can help them create more efficient strategies by saying, okay, well, if we have 8 plus 6, that means that I have 8 fingers and you have 6 fingers. And so if I want to add my fingers to your fingers, how many fingers would you have to give me so that I would have 10 fingers? And you can show this visually. And they'd say, well, you are you still have 2 fingers that are down. And so you would need 2 more fingers. And so you'd say, okay, well, if you give me 2 fingers, then you would still have 4 fingers. And so you can essentially break up the 6 into 2 plus 4. And then because 8 plus 2 equals 10, that is a core number in our number system. And so you'd have 10 plus 4, and that gives you the 14. And again, you don't need to write this out with your kids, but you need to help them develop the mental math strategy of basically creating groups of 10, because that can make addition a lot easier. So you can use thinking strategies like this, which help your kids understand the process of addition and multiplication in more detail, because understanding that making 7 copies is the same thing as making 5 and 2 copies is a deeper level of understanding of multiplication. So you can use thinking strategies to help your kids master the basics. You can also break down the memorization into manageable groups. So for example, if you're trying to memorize all of the times tables, the first thing that makes this a lot easier is to realize that if you have 5 times 4, that's the same thing as 4 times 5. And so if we look at the multiplication table and we say, okay, well, 5 times 4 is 20, and 4 times 5 is also 20, well, that basically means, if you extend this to all the rest of the times tables, that you don't have to memorize this entire half of the multiplication table, because changing the order of multiplication doesn't change the result. And then from there, you can break it down into smaller groups, and you can say, okay, well, what are the groups of math facts that have similar types of calculations? So for example, all of the 0 times tables, well, if you make 0 copies of anything, you're just going to have 0 things. So the 0 times tables are a really easy group. Same thing with the 1s, because if you make 1 copy of any number, you're just going to have that number. The 2s are also pretty easy because you just double. And the 5s are also pretty easy because you just take half of whatever 10 times it is. Because if you make 10 copies of something and split that number in half, that is 5 copies of the thing. So 2s and 5s are really easy because it just involves doubling and halving. And then the rest of the numbers, you can use other tricks, like the 9s have a really easy trick. And I'll show you on the next slide some tricks that you can use to memorize these yellow ones, which usually tend to be some of the harder calculations for students. So as the last thing when you're mastering the basics, you can use memorization tricks for your kids. So remember, you always want to make sure they understand the concepts first, and the thinking strategies can help them understand those concepts on a deeper level. But ultimately, you do want them to memorize the facts, and there's some different tricks you can use just to help them with the memorization. So one of my favorite memorization tricks is this book called Multiplication the Fun Way. And this book basically has a whole bunch of stories that have little mnemonics that help them memorize their times tables. So for example, when they're doing 6 times 6, they have 2 6s who are crossing a desert and they get really thirsty. And this little story helps them remember that 6 times 6 is 36 because you have thirsty 6s, and thirsty 6s kind of sounds like 36. So those stories can be a really helpful way for your kids to memorize their times tables. And another thing you can also do are different finger tricks. So there's one finger trick for the 9s that's very common. But there's also another finger trick that is less common that I haven't seen very many people use. And that's the one that allows you to multiply any number between 6 and 9. So the way that it works is you take the numbers that you're multiplying and you represent them on one hand with the number of fingers that's more than 5. So for example, the number 7 is going to be represented by 2 fingers because 7 is 2 more than 5. And the number 8 is 3 more than 5, so you'll hold up 3 fingers. And so these fingers that I've circled, you would hold up and then you'd fold the other fingers down. And the way that you calculate what 7 times 8 is you add the fingers that are up. So you would do 2 plus 3, and that gives you the number in the tens column. And then to find out what the numbers are in the ones column, you take the fingers that are down. So you have 1, 2, 3 fingers that are down and 2 fingers that are down on the other side, and you multiply those together. So you take the fingers that are up and add them together to get the tens column, and the fingers that are down and multiply them together to get the ones column. And this will work for any number from 6 to 9 if you multiply them together. And this can be another trick that you can teach your kids to help them memorize their multiplication tables. So to summarize, the 5 principles that I use to help make math easy for my students are playfulness, visualization, curiosity, application, and mastering the basics. So I hope that this seminar was helpful for you and that it will help you bring more ease and playfulness into your family's math experience. And if you're feeling kind of overwhelmed and you're like, I don't know how to do this like on a daily basis, or I don't have time to do this on a daily basis, I would really love to help make math easy for your family. And the things that I am offering this year are kindergarten through 2nd grade parent classes and 3rd through 5th grade student classes. So in the student classes, the students will get a daily video and a worksheet to practice the concepts on the video. And in those videos, I focus a lot on visualization and mastering the basics. With some application, but mostly it's just teaching the basic math concepts in those videos. And then once a week, we meet on Zoom to have our math adventures where we bring in the playfulness and the curiosity and the application. So that's for 3rd through 5th grade. And then I'm also offering parent courses for kindergarten through 2nd grade because with little kids, it doesn't really work very well to do Zoom classes. So instead of doing math adventures for kindergarten through 2nd, we'll be doing parent coaching calls to help you really understand how to build the foundations of math for your little kids. So if you're interested in either one of those things, you can sign up at middletonmath.com. You can also sign up for my free email list at middletonmath.com. To get those monthly emails with videos and suggestions of how to make math facts really easy. I will also be offering middle school and high school courses in the future, so you can also sign up to receive updates once those are offered. But for this year, I'm just offering kindergarten through 5th grade. So thank you so much for participating in this seminar. If you have any questions, feel free to reach out, and I would love to help make math easy for your family. So thank you so much, and I hope you have a great day.